All right. How do we find the area of a rectangle? There's a rectangle. How would you find its area? Excellent. And we usually make width the shorter side. So we would go length times width, right? Where do we find the length and width? Those are the sides of the rectangle. Hey, Mr. Morrison.
I don't see another one here, and there's one left. So
You're taking the second to last one of Staples?
last one, unless there's another box.
Nope. Okay, thank you. Who in here is going to remind me when I say go ahead and start working to call Betty? I know, right? I'm going to write it down. Okay. They're the sides of the rectangle, yes? And that gives us the area, yes? All right. What is a square? Okay. Pardon? All sides are equal. So it's a rectangle, but it's slightly different because L equals W, doesn't it? So we can still do L and W, except L and W are the same. So we don't need to use two different letters, do we? We can use the same letter, can't we? So let's go ahead and do that. What's the letter that we always use in math when we need an unknown? Right. So X, I wanted to change color there. X and X. So it's still technically LW, but since L equals W, we can rewrite it as X times X. And since math guys are lazy, what would they write there instead? X squared, which is where the name comes from. Because X times X will make a square. Everybody cool? All right. So, if we have the area of a square, then how can I determine the length of each side? Well, we already know that the area equals X squared, right? And we know that the area also equals length times width, which is also the side times the side. Correct? Everybody's cool to there? All right. If I give you the area, 4 equals X squared, how can you tell me how long each side is? What math do you do to find it? You don't need to divide by 4. You just need to square root. This is the square root, which you guys recognize from your Pythagorean studies as that symbol. Now that symbol has an actual name because it's not just the square root. All right? This is called a radical sign. I know, it is radical. What is sad but also radical is Stephen Hawking died today. Yes. And today is the ill-named Pi Day because it is the third month and the 14th day. 3.14. Stephen Hawking was 76. You know what else is ironic about Stephen Hawking? He was born, no, that's not ironic. That's just something that happened to him. What is, well, not really ironic, but is also interesting. He was born on the anniversary of Isaac Newton's death. I think it was Isaac Newton. He was born on the anniversary of some very famous scientist's death. And then he died on Pi Day. Now, really, Pi Day, that's just a 1 in 365 chance, right? No. He might have died yesterday on our time, but in London, it's 8 hours ahead. So if he died at 4 in the morning today in London, that was yesterday in our time. Because time is weird. Even more ironic is Stephen Hawking made a lot of money out of discussing the mysteries of time. Oh. Anyways, back to business. This symbol is asking you to find two identical factors. So when it was 4, if I write the square root of 4, I have to do 2 and 2 because 2 and 2 are the factors and they are identical. Everybody cool? You all know that from Pythagoras, yes? All right. Let us move on. Now I have a rectangular prism. How do I find the volume? Area of the base times the height, right? Now the area of the base, we talked about this a lot, it's the shape that repeats, yes? And since this is a rectangle, all 3 of these faces repeat, don't they? So I'm going to go ahead and call this guy W and L because it's the same rectangle we had up here. And then I'm going to call this guy H, right? Because H is the direction of repetition. Everybody's cool? So again, it's L, W, and H. Right? Now, what is a cube? It's a 3D version of a square, which means what are L, W, and H? What are they? They're all equal. So again, it's still LWH, but since L equals W and L equals H, what do we write it as instead? X, 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 which is X cubed. So, again, if you get the volume of a cube, it equals LWH, but it also equals X cubed. How could I find the length of each side? Well, when it was a square, we used a square root. We found 2 identical factors. Now it's a cube. I'm still looking for a root, but now I am looking for 3 identical factors. And how do I differentiate between 2 and 3? There's a little number right there. That 3 tells me I want 3 factors. Everybody cool? So here's the symbol again. There's that radical sign. Except this time, what's it asking me for? 3 identical factors. Now, you people are very intelligent young people. No number there, I look for 2. A 3, I look for 3. What do I do if it's a 4? What am I looking for? 4 identical factors. What if it was a 5? What if it was a 6? What if it was an X? You're looking for that amount of factors. X amount of factors, whatever it is. The small 3 is called the index number. Please highlight it. Underline it. Draw a cloud around it. I don't care. But know what it is because I will be saying it all the time. And that tells you how many factors we need. Okay? Everybody good? Now, you have all heard the term perfect square or perfect cube. All that means a perfect square has, actually, they both have these. Perfect square is any number with an integer square root or cube root. Actually, you know what? I'm going to change that. I'm going to change it to rational. Because I want to cover decimals, right? Remember, the square root of 16 is 4, so that's a perfect square. The square root of 12.25 is 3.5. Since it's rational, it's a perfect square. Everybody cool? Now, this sentence, please notice that it does not say, do this. But it does say, it is very valuable to do this. All right? So valuable that on the next page, page 92, I'm going to make you write them out. Start with the number 0 and then write its square below. What's 0 squared? 0. What is 1 squared? 1. 2, 4. Right? And keep going until this number equals 400. It won't take long. 3, 9, 4, 16, 5, 25, 6, 36. And of course, there is a pattern. And if you notice it, it will make the bigger numbers easier if you don't already have it memorized. Without using your calculator, just for fun, see if anybody has caught the pattern. What is 21 squared? The next one, without using your calculator. I'll give you all the seconds you need. It's a roof. 4. 441.
Yes.
What's the pattern?
It goes up by 2 each time. The number increases by up by 2 each time.
What?
The number each one increases by goes up by 2 every time. So 12 is 144, and then 144 to 169 is plus 15. Yeah.
Right.
Whatever.
Plus 15. Plus 17, plus 19, plus 21, plus 23, plus 25, plus so on, so on, so on. And you end up 41. So the next one is going to be 484 because you add 43. Everybody cool? Trust me when I say this. It is very beneficial to have these memorized. But you never need to. Do you understand what I'm saying? You can do all the work that you're ever going to do with your calculator and with simple math. But if you want to make your life easier and make your work go faster, having these memorized would be very, very helpful. Okay? Cubes are a little harder.
Oh. It's the, that goes up by 2 because it's square, and the cubes are going to go up by 3, so let's see, adding because of cube.
Well, let's see. What's 1 cubed? 1. What's 2 cubed? 2 times 2 times 2. 8. What's 3 cubed? No. 3 times 3 times 3. 27. What's 4 cubed? 64. 5 cubed?
145.
Yep. As soon as my calculator or my computer thaws, I will write 125. 6, 216. 7, 343. 8, 512. 9, 729, I believe. Let me do that real, yes. And 10 is 1,000. Now I want you to notice something about that guy and that guy. And I want you to notice something about that guy. Why did I highlight that guy blue and that guy blue?
Sure, they added a 0, but it's still 2 is 4.
Okay. Then I'm going to highlight another thing blue. Why did I highlight that guy blue?
You multiply them together.
What do you mean by that?
20 times 400, or 10 times 10, which equals 1,000. 2 times 4.
So in this blue one,
3 times 9 is 27.
in here, the square root of 400 is the same as the square root of 4 times 100. Right? Everyone cool with that? Yeah? All right. So, actually I didn't want to highlight that guy yet. We're going to deal with him later. Everybody cool? All right, now, notice the next page, the next thing says this. I have talked to death about how important estimating is before you go to your calculator, right? Because if you punch something into your calculator wrong, you guys believe your calculator, no matter what it says. If I asked you to add 7 and 5, and somehow you hit 7 and 4 and equals and got 11, you would tell me that 7 plus 5 is 11. You all would. You might notice it, but some of you wouldn't. I know some of you wouldn't, because on the trig tests you just did, many of you told me many, many times that the hypotenuse was shorter than the other two sides. Why? Because your calculator showed you that, and you wrote it down anyway. You laugh when I use the example of 7 plus 5 equals 11, and you would all write that down. And yet, that is exactly what you do, because you refuse to take 1 second and estimate. So I'm going to make you estimate 6 times right now. So I can at least say for my own edification that I have tried everything in my power to make you do this. You will still ignore me, and that's okay, because then it's on you. Aight? So, how do we do this? You did this in the 9th grade. You should have no trouble with it. You do not need a calculator for this job. Everybody should have their calculator hidden away from them so as not to even tempt you to touch it. Because I am already seeing people punching these numbers into their calculator. Even though I have gone out of my way to say numerous times that you should not touch your calculator when estimating. So let's do this. 72. Please look. Is that a square root or a cubed root that I am seeking? How do you know that, Mason? It's got the sign, and does it have a little number in front of it? No, so I'm looking for the square root. So I go up onto my list up here, and I'm looking for the square root of 72. Do you see 72 in any of these perfect squares? No, you do not. What do you see? 64 and 81. Since 72 lives in the middle, logically, the square root of 72 must live in the middle, yes? So, it is 8 point something. That is a great estimate. You know it's 8, and you know it can't be 9. That's good enough. If you want to estimate a little better, here is what you do. 8 squared is 64, correct? 9 squared is 81, correct? It'll show up in a second. The root of 72 is 8 steps past 64, isn't it? Right? And how far is it? This is 8. How far is it all the way to 81? 17. It's 17, isn't it? I took 8 out of 17 steps, yes? So it's 8, and then I took 8 out of 17 steps. Now, you look at that very closely. What is that 17 close to that works well with 8? 16. So it's 8 and 8/16, which is pretty darn close to 8.5. Now, I go to my calculator. Now I am going to go to my calculator. Square root 72 equals 8.48. What was our guess? 8.5. Everybody with me? What?
When I was doing it myself, I just kind of went in the same direction as you, except instead of rounding it down to 16, I just assumed that it would be 4 and then almost 5, so it'd be like 4, 8.
Sure. That's fine too.
I was just surprised how close I thought.
Yeah, that's my point, right? Now, if you went and did the whole question with that square in it and got some crazy answer, you should be able to sort yourself out. So what's 180 between? Look on your list. So 13 and 14, yeah? 169, 196. So that is 13 and a bit, right? You want to get a little more exact? 180, that's 11 steps out of a total of what? 23? 27. 11 out of 27, yeah? Again, pretty darn close to half, isn't it? Little less than half, right? Kind of close to a third, too. So we could say 13.3, 13.4-ish, right? Now go to your calculator and tell me what the square root of 180 is. Hola! Everybody got it? 300. What's that? $17 and $18, yeah? 289, 324. That's 35, right? I went 11 of those. So it's 17 and 11 out of 35. What number on the bottom works well with 11 instead of 35? It'll show up in a sec. 33. That's pretty darn close, approximately 17 and 11 over 33, which is 17.3. Everybody cool? What's different about D, E, and F? They're cubes. Are you going to use the same scale? No, but are you going to use the same method? Sure you are. 45 is between what and what? 3 and 4. 27 and 64. Yeah? Now again, we're just estimating. That's approximately 40, yes? And 27 to 45 is approximately 20, yes? So isn't this 3 and 20 out of 40? Which is pretty close to 3.5. Now, I want you all to grab your calculators again because I want to actually show you how to do this because some of you don't know. We had it in the first unit, but I want to remind you again. How do you find, when you do need to find an actual number, how do you use your calculator to find cubed roots? My calculator is very easy. I hit this math button, and it's right there. See? Number 4. Cube root. Right? Most of you on your calculators have a cubed root button. It'll show up in a second on the screen. Most of you have that. It looks like the symbol that we wrote on our first notes. There's a little 3 and the root. Please look on your calculator and try to find it. It is often a second function key, like shift sine, shift cos, shift tan. Everybody see if you can find yours. Does everybody have it? If you don't, you may have this one, x root. If you have x root, then you'd use it similarly to the way we did trig. You want a cubed root? So usually you push 3 x root and then whatever your number is, 45. But you might have a backwards calculator in which you have to go 4, 45, x root 3. Everybody try to do it, and you should get a number around 3.5. 3.55. Can everybody find cube roots? Yeah? I'll just wait a moment to make sure everybody can do it. Again, if you're still using your phone calculator, this is very difficult. Go and buy a calculator. They're $9. $99 problems and a calculator isn't one? Good job. Wait. Let's have some fun with this. No, because the song is 99. So that's not good. You could have to change the number, right? I got 10 squared problems, but a calculator isn't one. All right. I got 10 squared problems minus 1, but a calculator isn't one. Okay. Everyone is good? All right, now, you should have a little bit of white space at the bottom before I let you go. You need to use your brains. What does that symbol mean? No. Yeah, it means the square root of x, which means I'm looking for two equal factors that will multiply to x, yes? Okay, no matter what is under there, that is what I am doing. Everybody cool? So what if I add this? The square root of xy. Now what would it be?
The two factors that together do the same thing as x and not together.
Exactly. So that would be the square root of x times the square root of y. Everybody with me? Because the square root hits everything, just like an exponent. Everybody cool with that? What if I gave you this? The square root of x over y. What would that be? Using your brain, using what you know. Really? When the square root sign went over both of them, we square root both of them. Is the square root sign going over both of them? Is it covering all of it? So what do? We square root all of it. Just like we would do exponents. Everybody cool? All right. Turn the page over, and page 93 and 94 and 95 are your work. Now listen. Listen to me, please. You are on page 90, 93. You can go ahead and use your calculator. All right? Remember, if the decimal ends, it's rational. If it doesn't end, it's irrational. So page 93, go ahead and use your calculator. So on page 94, if it's irrational, so you can use your calculator to see if it's rational or not, but don't. I would rather you didn't. If it's irrational, then I want to see an estimate, like from our notes, what we just did. Everybody understand?
Wait, so rational is just whole numbers?
Rational is if the decimal ends when you do it. So, I'll give you an example. In this first one, it's cubed. Is 576 anywhere on our cube root list? No, it isn't. Right? So this one we know will be irrational. If it's irrational, then I want an estimate like we did in our notes. Everybody cool? And then page 95 is just two questions that we actually already did. Everybody good? All right, you do that. I am going to come around and get your quiz score out of 14 whilst I am walking around. You will be working on this. Remember these properties, and remember this property. You can break them down into smaller numbers. Everybody cool? Go. I'll throw you to your hands next time.